Imagine a future where you can soar above the congested streets, reaching your destination in record time. This is no longer a distant dream but a reality unfolding before our eyes. Elon Musk has just unveiled the world's first true flying car, the Tesla Model A, and it promises to revolutionize everything we thought we knew about transportation. This groundbreaking vehicle is set to change the way we travel, making traffic jams a thing of the past and transforming urban mobility forever. In this video, we will explore the technology, challenges, and potential impacts of the Tesla Model A on our society. One of the most critical components of the Tesla Model A is its propulsion system. Unlike traditional airplanes or helicopters that rely on fossil fuels, the Model A uses a complete electric system powered by Tesla's highly advanced battery packs. The heart of this system lies in its multiple ducted electric fans, which provide both lift and thrust, enabling vertical takeoff and landing capabilities. This allows the vehicle to operate in tight spaces where conventional aircraft cannot. The battery technology used in the Tesla Model A is the result of years of innovation and billions of dollars of investment. Tesla's battery cells are renowned for their energy density, durability, and fast charging capabilities. Integrating these batteries into a flying car posed significant engineering challenges, especially in managing heat and ensuring consistent performance at high altitudes. However, Tesla's expertise in battery management systems has overcome these hurdles, providing a stable and efficient power source for both ground and aerial travel. Another standout feature of the Tesla Model A is its autopilot and navigation systems. Leveraging Tesla's advancements in artificial intelligence and machine learning, the Model A's autopilot system is a marvel of modern engineering. It uses a combination of cameras, lidar, radar, and ultrasonic sensors to create a comprehensive understanding of its surroundings, both on the ground and in the air. This allows the vehicle to make real-time decisions to avoid obstacles, adjust its flight path, and ensure passenger safety. Tesla's AI is constantly learning and updating, making the autopilot system more reliable over time. Safety is paramount when it comes to flying vehicles, and Tesla has gone above and beyond to ensure that the Model A meets the highest standards. In addition to its advanced autopilot system, the vehicle is equipped with redundant safety features designed to handle emergencies. These include backup power supplies, multiple flight control systems, and emergency landing protocols that can be activated in the event of a critical failure. Perhaps the most reassuring feature is the ballistic parachute system, which can deploy quickly to bring the vehicle safely to the ground if all other systems fail. However, technological safety is only part of the equation. Regulatory approval is a significant barrier that Tesla must overcome to make flying cars a common reality. The current air traffic control systems were designed long before the concept of personal flying vehicles was even considered. To integrate flying cars into the existing framework, Tesla has been working closely with the Federal Aviation Administration, FAA, and other global aviation authorities. This collaboration involves developing new standards for air traffic management that can accommodate the unique requirements of flying cars. Tesla is also pioneering a new approach to airspace usage. The Model A will primarily operate in low-altitude urban airspace, an area that is currently underutilized. By establishing designated flight paths and zones specifically for flying cars, Tesla hopes to minimize conflicts with traditional aircraft and create a new layer of urban mobility. This approach requires not just new regulations but also advanced software to manage these flight paths dynamically, ensuring that the skies are as orderly and safe as our roads. The introduction of the Tesla Model A will inevitably have profound implications for urban planning and infrastructure. Today's cities are designed around ground transportation, cars, buses, bikes, and pedestrians. The advent of flying cars will force city planners to rethink how space is utilized. Parking lots, streets, and even rooftops will need to be adapted to accommodate these new vehicles. For example, we may see the rise of skyports, dedicated landing zones that allow flying cars to take off and land safely without disrupting other forms of transportation. These skyports could be integrated into existing structures like office buildings, shopping malls, and even residential complexes. Imagine a future where your daily commute involves simply stepping out of your apartment, taking an elevator to the rooftop, and hopping into your personal flying car. The potential for reduced commute times and increased convenience is enormous. However, this also raises questions about accessibility and equity. Will flying cars be available to everyone, or will they remain a luxury for the wealthy? Addressing these issues will be crucial to ensuring that the benefits of this technology are widely distributed. Another significant impact will be on the existing transportation infrastructure. Roads, bridges, and tunnels require constant maintenance and upgrading, which is both costly and disruptive. A shift towards flying cars could alleviate some of this burden by reducing the wear and tear on ground infrastructure. However, this doesn't mean that roads will become obsolete. Flying cars will complement rather than replace traditional vehicles, offering a new layer of mobility that enhances our current transportation system. One of the most compelling aspects of the Tesla Model A is its potential to reduce the environmental impact of transportation. Traditional cars are a major source of greenhouse gas emissions, contributing significantly to global warming and air pollution. By contrast, the Tesla Model A runs entirely on electricity, and when powered by renewable energy sources such as solar or wind, it can operate with zero emissions. Moreover, the Model A's efficient use of airspace can lead to shorter travel times and less congestion, further reducing its environmental footprint. The electric propulsion system is not only cleaner but also quieter than traditional engines, which means that flying cars could help reduce noise pollution in urban areas. This is particularly important in cities where noise from road traffic is a major source of stress and health issues. However, the environmental benefits of the Tesla Model A are not guaranteed. The production of batteries and electric motors requires significant amounts of energy and raw materials, some of which have environmental and ethical implications. Lithium, cobalt, and other key components of batteries are often mined in ways that can be harmful to the environment and exploitative to workers. To truly make flying cars a sustainable solution, Tesla and other manufacturers will need to invest in more sustainable and ethical supply chains. The Tesla Model A isn't just a technological marvel, it also has the potential to reshape the economy. As with the introduction of any disruptive technology, there will be winners and losers. Industries that rely heavily on traditional modes of transport, such as car manufacturing and road maintenance, may face significant challenges as demand shifts. On the other hand, new opportunities will arise in sectors such as air traffic management, urban planning, and vehicle manufacturing. The job market will also be affected. Pilots, traffic controllers, and automotive engineers may need to adapt to new roles as flying cars become more prevalent. Tesla has already begun investing in education and training programs to prepare the workforce for these changes. The company envisions a future where piloting a flying car is as simple as driving a car today, but until that vision is fully realized, there will be a need for skilled professionals to oversee the transition. From a social perspective, the introduction of flying cars could have profound implications for how we live and interact with one another. For instance, the ability to travel quickly and easily between cities could lead to a more interconnected world, where living in one city and working in another becomes commonplace. This could have far-reaching effects on real estate markets, as the demand for housing in traditionally commutable areas shifts. On the flip side, there are potential downsides to consider. The convenience of flying cars could exacerbate issues such as urban sprawl, as people choose to live further away from city centers. This could, in turn, put pressure on already stretched resources and infrastructure. There's also the risk that flying cars could widen the gap between the wealthy and the less affluent, particularly if the technology remains prohibitively expensive for many. For flying cars to become a mainstream mode of transportation, public perception and acceptance are key. Historically, new transportation technologies, from trains to airplanes to electric cars, have faced skepticism and resistance before gaining widespread acceptance. The Tesla Model A will likely be no different. Public concerns about safety, privacy, and the environmental impact will need to be addressed if flying cars are to take off in a big way. Tesla's brand, however, gives it a significant advantage in this regard. Elon Musk has built a reputation as a visionary who delivers on bold promises. Tesla's success with electric cars and SpaceX's achievements in space exploration have earned the company a level of public trust that few others can match. By leveraging this goodwill and continuing to demonstrate the safety and reliability of the Model A, Tesla is well positioned to overcome initial skepticism. Marketing and education will also play crucial roles in driving adoption. Tesla will need to invest heavily in demonstrating the benefits of flying cars, not just in terms of convenience and performance, but also in how they can improve quality of life. Public demonstrations, media coverage, and pilot programs will be essential tools in building confidence and excitement around this new technology. The future of mobility. As we look towards the future, the Tesla Model A is just the beginning of what could be a complete transformation of how we think about mobility. Elon Musk has already hinted at plans for larger, more advanced versions of the flying car, including autonomous flying taxis that could operate in cities around the world. This could lead to a shift away from personal car ownership towards a more service-oriented model of transportation, where people pay for access rather than ownership. This shift has the potential to make transportation more efficient and equitable. Autonomous flying taxis could provide affordable, on-demand transport for people who can't afford a personal vehicle, and they could help reduce the overall number of vehicles on the road and in the sky. By optimizing routes and pooling passengers, these services could also make better use of resources and reduce environmental impact. Furthermore, the technology developed for the Tesla Model A could have applications beyond personal transportation. Drones and other autonomous aerial vehicles could revolutionize industries such as logistics, agriculture, and emergency services. Imagine a world where medical supplies can be delivered quickly and safely to remote areas, or where traffic accidents can be surveyed and addressed by autonomous drones in real time. The Tesla Model A represents more than just a new type of vehicle. It embodies a vision of a future where the boundaries of mobility are redefined. As Elon Musk continues to push the envelope of what is possible, we stand on the cusp of a transportation revolution that could transform our cities, our economies, and our way of life. The sky is no longer the limit, it's just the beginning. Stay tuned as we continue to explore the innovations that are shaping our world and paving the way for a new era of mobility.